So using the second derivative. So in PM1, you've had an exposure when we differentiate something twice. Yeah, we say we find in d squared y over dx squared. Okay, so just a quick reminder. All right, so copy that down. All right, so let's have a look at these three questions. It says find the interval. The first question, we're going to work in this order. This one first, and then this one, and then we'll work on this one last. So find the interval on which the function f of x is equal to x cubed plus 4x plus 3 is concave. So what have we just been told about something being concave and its second derivative? What does it have to be? Less than or equal to 0. So for something to be concave, it has to be, the second derivative has to be less than or equal to 0. So we will find the second derivative. So if we have f of x is equal to x cubed plus 4x plus 3, the first derivative will be 3x squared plus 4. And the second derivative, which we need for this, will be 6x. So now we make this 6x less than or equal to 0. So therefore, 6x is less than or equal to 0. And then what will x be, guys? X will be less than or equal to 0. So this is the range of values for which this function is a concave function, or is concave. Is that good? All right. So let's have a look at the next one. It says show that. So this is a show question. So step number 1. What have we been told about convex? That the second derivative has to be greater than or equal to 0. So therefore, we are going to find the second derivative of that. So if that's the original, the first derivative will be 2e to the 2x plus 2x. Okay, so that's the first derivative. The second derivative will be 4e to the 2x plus 2. And this is now going to be made to be greater than or equal to 0. So therefore, 4e 2x plus 2 will be greater than or equal to 0. So how do I show that for all real values of x, it's going to be convex? How will I show that? Well, we've got the plus 2 here. That's always going to be greater than 2, right? But we need to work and figure out an explanation for this part. Now, what do we have here? We have the exponential function. What do we know about the exponential function? That it crosses at 1, yeah, on the y-axis, right? It crosses at 1. And it has to be greater than 0, okay? It has to be greater than 0. So therefore, if this is greater than 0 all the time, okay? So you've got a positive here, greater than 0, and you're adding 2 more. So therefore, all real values of x will satisfy this. And therefore, it will be, the second derivative will be greater than or equal to 0. So let's have a look at the last question. It says the curve C has an equation y is equal to x cubed minus 2x squared minus 4x plus 5. Find the coordinates of the point of inflection. So we want to find the coordinates of the points of inflection. So because we want to find the point of inflection, what do we have to write down first? The second derivative is equal to 0. All right, so let's go find the second derivative. Now here we're using y. So when we find the first derivative, it's going to be dy over dx. And the second derivative will be d squared y over dx squared, which is exactly the same thing as f dash dash x, as we know. Yeah? Okay, so if anyone's confused about that, then that's what it is. 3x squared minus 4x minus 4. And the second derivative will be 6x minus 4. So now we are going to make this equal to 0. So we're going to have 0 is equal to 6x minus 4. And we are going to solve that. So what's x going to be equal to here? It's going to be, take the 4 to this side, divide by 6. So you get 4 over 6, or simplified 2 over 3. So our x coordinate is 2 over 3. We're going to substitute this to find our y coordinate. Where do we substitute this in? Into the original y. So therefore, y would be equal to 2/3 cubed minus 2 times 2/3 squared minus 4 times 2/3 plus 5. And if you could just put this into your calculators and give me your y coordinate, please. 47/27, yeah? So we've got 47/27. So therefore, our point of inflection would be our x coordinate, which is 2/3, and our y coordinate, which is 47/27. So this covers everything for exercise 9I. Okay? Next, we'll be looking at rates of change and looking at exercise 9J.